Hello, welcome to the introduction of the System Requirements Engineering training of the High-Tech Institute. My name is Cees Michielsen and I'm happy to introduce to you this wonderful training. We start with looking at the requirements engineering process, and as you can see it's a cyclic process, and we start with something called elicitation. Elicitation is all about finding your stakeholders, making sure you have all your stakeholder needs in view and you understand what their needs are. Second step is the analysis. During the analysis, we will have a look at the functions, the properties and the constraints of the product. We will try to bring together all the information we have from the stakeholders, from the business itself, from research, from everything around it. We'll have some conclusions about that analysis. We call them analysis statements, and those statements are input for what we call the next process step, and that's the requirements writing. In that specification step, we will focus on the quality of requirements, of course. And the step after that, verification and validation, will ensure that we have not forgotten to think about our stakeholders in terms of have we written our requirements in such a way that they really represent what the stakeholder need. And secondly, we will write those requirements in such a way that the ones who need to find solutions for the requirements, let's say the designers, and for those who need to find test cases for them, that they really understood these requirements. And that's something we call fitness for use. As a fifth step in that cycle, we will look at the management side of requirements. We will talk a lot about not the individual requirement themselves. We of course apply all the configuration management aspects, or version management, status accounting. Perhaps more importantly, we will also consider a set of requirements, we call that baselines, to be released in the next step. In the release step or publication step, we will ensure that all those that need to have access to the new baseline have access, to make sure that version control is also managed at that level. When we look at requirements quality, we will answer the following questions, amongst others, of course. So what exactly is it that we mean with the quality of a requirement? What determines the quality of a requirement? Is there a difference between the intrinsic and the extrinsic quality of a requirement? Are there any tools that can help us? And perhaps we can learn from the past, from people like Joseph Joran, Philip Crosby and Edwards Deming. And of course, during the training, we will have lots of time to discuss your ideas on quality of requirements, where you think that we can improve on that. When we talk about system requirements engineering, we also should be able to place that in context of product engineering or systems engineering. Usually we begin with requirements engineering, having the baselines as an output of that process, and that baseline is again input for the design process. The design will try to find one or more solutions for those requirements, and in the decision-making process we will decide upon which of these solutions is best fit for us. Once we have decided, we document that decision, and in such a design decision, it's really a statement that makes it very clear which part of the design addresses which requirements at that same level. So you can imagine that the relation between a design decision and a requirement is a very important element of the traceability of requirements. You can also imagine that during that design, we will have several assumptions about the capabilities of subsystems or components that are part of that higher level design. Those assumptions will be translated to requirements, and they will be linked or traced to the design decision that explicitly says, okay, these requirements at system level are satisfied by this design, and it will lead to these requirements for the subsystems and the components. So these requirements will be called derived requirements from the higher level. Another concept that we will have a look at is the so-called W model. And the W model makes it quite explicit how the system is decomposed into, on the one hand side, the functional decomposition, and on the other hand, the physical decomposition. It's called the W model because we have two right legs, in fact. The first right leg is the full responsibility of the development team, needing to demonstrate the full functionality, but also the requirements that are associated to the physical system, like mass and volume. Once that is done, once the development team has demonstrated that these requirements are met, then we can start implementing. So we can start constructing, programming, etc. A third element in the context of requirements engineering is the entities that are produced during the process activities. We will find records in a database type of environment that have information about the stakeholders, about the stakeholder needs, the analysis statements, the requirements. So it's very important to understand what the dependencies are, the coherence between those entities, and we will use that semantics to understand how the trace from top to bottom, but also from bottom to top, really takes place. So in summary, we will look at the product engineering process as the context for requirements engineering. We will talk about the several abstraction layers, the design decisions, and traceability in there. We will have a look at the functional breakdown and the physical breakdown and the different perspectives that we will have when we talk about the W model and the consequences for requirements in that. And we will also see how complex or how easy it is to relate analysis statements, requirements, and design decisions in such an order that we can really trace from top, the very top, even to the stakeholder need, to the very bottom, the implementation design decisions. So where we could find the trace all the way to why do we do this, why do we have this requirement, and why does it have this value. Those are really the two basic questions that we should be able to answer throughout the whole structure. We will also talk about tooling, because requirements management without tooling is a tough job. We also look at some tools that help us writing requirements and verifying requirements. There are two topics, and it may surprise you perhaps a little bit, but two topics that we like to get rid of, and those are requirements trees. So requirements trees, they suggest that requirements are depending on each other or are derived from one another. This is definitely not the case in practice. And another phenomena that we try to get rid of is the V model. A V model being a perfect model for very simple products like where you have the highest level, the system level, let's say, and component level, and nothing in between. As soon as we talk about the other type of products, for instance, a car having, let's say, a braking system, a steering system, a suspension system, and many more systems in between the vehicle layer and the component layer. The V model suggests that we have on the left-hand side a requirement specification and designs for that particular system. That design will, of course, consist of several components. But what we do not do in practice is we do not integrate them as a whole separate system, as a separate physical module. All the components are distributed in the car, in the vehicle. There is no braking system on the right-hand side of the V. It's also not part of the bill of material. That's something that we should understand. Fortunately, we have a good alternative, being the W model, and the W model will help us to get rid of the old, what I would call the last century artifacts, like the V model. as soon as possible. There is one other thing that has come up during the past year, and that's the artificial intelligence that could be beneficial for us as requirements engineers. And so we will definitely have a look at that. The things I've seen so far are very promising, and I think we could really benefit from that development there. Okay, so of course we will have a lot of time during the training and during the exercises to answer your questions. We will start the training in the morning of the first day by having a sort of an inventory of your questions, your expectations, and your use cases that you brought along. And during those 2 days, we will answer them when it is appropriate. So I thank you very much for watching this video, and I hope to see you very soon.